You know, some of the stuff that we dealt with last Friday is going to repeat on this also. When you think of parabolas, we have either a high point or a low point, depending on which way it opens. If it opens up, for instance, so something like this would be an example of having a minimum value because it does have a lower spot. Like the Golden Gate Bridge over there, the ropes that are like the cables on the bridge itself, that is a parabola that opens up or it comes down like that, so therefore that would be a low spot or a minimum. If it was like the arch in St. Louis, that's a high point, or this would have what we call a maximum. Okay, so we're going to deal with mins and maxes. And the other piece to what we're going to do is we're going to figure out whether or not the thing increases or decreases. So as you're working from left to right, we're going to have a function being increasing versus decreasing. Now on this minimum one, if you're going this way, pretend you're on a roller coaster and you're coming down the roller coaster. Are you increasing or decreasing? I'm not talking about speed. Your speed obviously is going faster, but you are going down. Decrease. So you're decreasing as you're coming down. Then when you hit that minimum spot and you start to turn back up, then the function itself when you're going uphill would be what? Increasing. Okay. Now, looking at the one that goes down, when you first start, would you be increasing or decreasing? Increasing, because you start going up the mountain first. And then once you hit that high spot, then you come down the mountain, you would be what? Decreasing. Now, how you're going to write that is you're going to use like x is less than this side or greater than this side, or vice versa. That's how we're going to show that increasing and decreasing. Okay? Again, there's one number that will tell you what kind of way it goes. If a is greater than 0, it's going to open up. And if a is less than 0, it's going to open down. So if it opens up, it's going to have a minimum. If it opens down, it's going to have a maximum. Okay? How you actually find the minimum and maximum, you already know. And we did it last week. In order to figure out the increasing and decreasing, or the max where it's actually at, negative b over 2a is one of the items that you'd need. What was that we did on Friday that's negative b over 2a?
Line of symmetry.
The axis of symmetry, or the x-coordinate of your vertex. Right. The minimum and maximum value is when y equaled, and then you inserted, or what you did was you plugged in number. And that was for the y on your vertex. Now, when they ask you what the minimum value or the maximum value is, it's the y coordinate. That's what it is. So when they say what is the minimum or maximum value of the function, they're asking you for what's the y coordinate of the vertex. Do I have to graph this stuff at the beginning? No, I don't. If it helps you, we can. But all I'm going to do is give you a problem, and it's going to say we have to figure out if it's a minimum or maximum, or find it. Okay? So, on something like this, where it has y equals 6x squared minus 1. The first thing I'm going to ask you is this going to open up or down?
Up.
How did you know it was going to open up, Danny?
Because 6 is positive.
Because the 6 is positive, it's going to open up, so therefore that's a minimum. We're going to have a minimum there. Now, where is that at? So I have to do the negative b over 2a, just like I did on Friday. What number's in the b position?
There isn't.
0. There isn't a b. Okay, remember it was ax squared plus bx plus c. There is no x. So therefore our b is 0. What number was in the a position? 6. Negative 0. What number is that? Just 0. Divided by 12 is still going to be 0. Now, to get the y coordinate, you plug in 0. What's 0 squared?
0.
Times 6.
0.
Minus 1.
-1.
Now, to answer the question was, what's the minimum or maximum value of this function? The minimum is -1. Again, how did I know if it was a minimum or maximum? I looked at the a. If a is positive, it's going to be a minimum. If a would have been negative, it would have been a maximum. That's the difference. And then the -1 was the y coordinate that we got out. Awesome. The second part to it is going to say, describe the domain and range of the function. Domain and range we have done a long time ago. Domain and range was the x values and the y values. The x values. When I had all those parents up there at the beginning, the domain, I already told you guys, for every single one of those first 4 parents was what? You guys remember? All real numbers. The domain is going to be all real numbers for every single one of these. There's no domain restrictions. I don't have any fractions, or I don't have anything that would warrant me having anything different. So all real numbers is what the domain is. Now, the range. As you guys have already told me, you guys told me that this thing opens up, which means the low point's at -1, and it goes up forever. Right? So my range would be y is greater than or equal to -1. Where did I come up with the -1 at?
That minimum.
Yeah, the minimum. If it would have been a maximum, I would have flipped it over and said y is less than or equal to whatever that would have been. Okay? Now, the other part is going to ask you for, then tell me when the function is increasing versus decreasing. So it's 3 parts. If it opens up, you said on the left-hand side, was that increasing or decreasing?
Decreasing.
Okay. So, wow, that's pretty good. As you're going this way, is this thing going downhill or uphill?
Down.
So you're decreasing when x is less than 0. And then what happens when we hit this spot?
You go up.
Then we go up, so then we're increasing when x is greater than 0. Where did I get the 0 from?
There's no b.
Where you?
Right, the negative b over 2a thing. That's where I got it from.
So you're at
Okay? So on that position, or it's the x coordinate of the vertex. This would be the answer that we're looking for the first couple problems. It wants you to tell me if it's a minimum or maximum, and then the number that you get. Then the domain and range, which, by the way, what's the domain for every single one of them? Good. Range was the same as the minimum or the maximum. And the increasing and decreasing, where did I get the 0 from? The x-coordinate. So realistically, what I did was I picked everything out of the vertex. Yes, Danny?
Or minimums, always negatives.
No. It just depends on where the bottom, where that number that you got. So in that case, when I put in x and I got -1 out, that was my minimum. If you would have put in a number and got out 50, then 50 would have been the minimum. It doesn't have to be negatives. Just depends on where it is.
How did you do the increase and decreasing thing?
Okay, so if this is my picture, as I'm going from left to right, it's going downhill to start. Because you imagine like if you put like a marble on here, it's going down, so it's decreasing, and then increasing would come out this way because you're going uphill. How I got this number right there, or the number that I had the 0 on it, it's the x-coordinate. That's what we got when we did the negative b over 2a thing. Okay, let me give you another one.
No good.
Y equals negative x squared minus 4x minus 2. Negative x squared. I think I just said x squared. Negative x squared minus 4x minus 2. Okay, first things first. What number is in the b position?
4, negative.
Negative 4. What number is in the a position?
0,
Negative 1.
1.
If there is a letter there and there's no number in front of it, it's supposed to be understood to be a net of 1. In this case, negative 1, because there's a negative sign.
Oh,
On the top, what do two negatives make?
Positive.
On the bottom, what's 2 times negative 1?
Negative 2.
What's 4 divided by negative 2?
Negative 2.
Okay? Right now, we know that negative 2 is the x. By the way, that's going to help us for the increasing and decreasing parts. Okay? Now, to get the y coordinate, what do I do? Plug it in. Plug it in. Negative 2 squared. What do you get?
oh, that's
2.
That's 4. And then you have a negative on the outside of that also, so that makes negative 4. What's negative 4 times negative 2?
8.
8
Would be plus 8, yeah.
minus 2. What's negative 4 plus 8
2.
minus 2?
2.
2. Now, that 2 is the minimum or maximum value. Is it a minimum or a maximum?
Maximum.
How did you know it was maximum this time?
There's a
It's
negative.
great.
Because A is negative. If A is negative, that means it's going to open down. Okay? So, if we really needed to, we could graph this. You don't have to, but if I did, 1, 2, up 1, 2, make dot, negative 2 is my y-intercept, 2 over. It would come in here something like this. That's what it would have looked like had I graphed it. The directions do not ask you to graph. I just did it so that way you guys had a picture to go off of. Does that make sense? Now you guys already told me that 2 was a maximum. So I'm just going to put right behind it max so that I knew that you knew if it's minimum or maximum. What's the domain? All real numbers. What's the domain for every single one that we do? Right. The range has to deal with the maximum or the minimum.
Y is greater than or equal to 2.
No.
Less than.
Close though, Jay. On this particular thing, if you said greater than, we would go up.
Oh, we're going down.
We're going down, so it'd be y is less than or equal to 2, since the number opened down. This right here, the range, is either going to be y is less than or greater than or equal to, or greater than or equal to. If it goes up, it's greater than or equal to.
So how would we know without graphing?
Looking at the a. If a is negative, then this should be less than.
It would be maximum.
And then that would be a maximum. Right. If it was positive, then it would be a minimum, and it would say y is greater than or equal to whatever number we got. Okay? Now, as far as the increasing and decreasing, as you work from left to right, is the thing increasing or decreasing as you go? Is this going uphill or downhill? It's going uphill to start, right? Until you get to what number?
2.
Negative 2. How'd you get the negative 2? It's the x, right? So x, so it's increasing when it's less than, not equal to. Negative 2. And it's decreasing from when? When it's greater than negative 2. What does greater than negative 2 in that context means? It means to the right. And less than negative 2 means to the left when it's on the axis. Okay? Now, the last half of your assignment today is one more graphing type. I have one more formula for you. It's f of x equals a, x minus p, x minus q. And it'll be written like that, like a factored form. Okay? P and q are the x-intercepts. That's what P and Q are. And in order to find the x for the axis of symmetry or also for the vertex, we take whatever P is plus whatever Q is and we divide it by 2. That's how we find the x. How do you find the y coordinate then if you know the x? Right. You plug in x.
So is it always going to be P plus Q over 2?
Yes.
And P and Q are the x-intercepts, right?
P and Q are the x-intercepts. Yes.
So we plug in x for P and Q and add
Nope.
into-
For x. You'll have P and Q already.
Oh, okay.
So, f of x equals x plus 3, x minus 3. In order to get your P and Q, all you do is set each of your parentheses equal to 0 and solve. So x plus 3 equals 0, x minus 3 equals 0. What do I get?
X equals negative 3 and x equals 3.
X equals negative 3 and x equals positive 3. What we just found there is we just found the x-intercepts. How many x-intercepts are there? 2. How many points does it take to make a graph?
1, 2,
3. You've just found 2 of them. You need to find the third.
So we just plug that in.
So here's how I get that. If I put the x's on there, 1, 2, 3, make dot, 1, 2, 3, make dot. What number is halfway between 3 and negative 3?
0.
Right. Or if you were to take 3 plus negative 3 divided by 2, you would get 0 divided by 2, which is 0. So, what I just did there out loud instead of writing it down was I did this. I was finding the x, which is also my axis of symmetry when x equals 0, which is right down the y-axis. It's kind of hard to see that, so I'm just going to dot it around it. And then in order to get the y-coordinate, plug in 0. 0 plus 3 times 0 minus 3. What's 0 plus 3?
3.
What's 0 minus 3?
Negative 3.
What's 3 times negative 3?
Negative 3.
Negative 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my vertex.
A lot of dots.
No, it's only 3 of them.
Well, I mean, it's a lot of spaces down.
It is a lot of spaces down. But I now have enough to make my parabola. So when you get to problems like this, whatever's inside the parentheses set equal to 0, and that's your x-intercepts. Then find the halfway point. That's your axis of symmetry. Then put that number in, and that will give you what your vertex is. Let's do another one. Y equals x plus 1 times x minus 3. Okay? So, first things first. If I set each group equal to 0, x plus 1 equals 0, what would I get for x?
Negative 1.
Subtract 1 to both sides, and I get x equals negative 1. Good. X minus 3 equals 0.
X plus x3.
Add 3 to both sides, and I get x equals 3. Is everybody okay with that step first?
Yeah.
Okay. Now, the other thing is, every single one of the ones that you have to do that are like this already have it in that type of format. It's not like you have to factor it to get it that way. It's already set up for you like that, okay? Now, if I plot those ordered pairs or plot those on there, 1, 2, 3, and 1, there's the x-intercepts. Now, if I'm not capable of figuring out just by looking at it which one is right in between them, -1 plus 3 divided by 2 is how much? What's -1 plus 3?
3, 2.
2. What's 2 divided by 2? 1. So at 1 is my axis of symmetry. Now in order to figure out what the vertex is actually at, what number do I put in? 1. 1 plus 1 times 1 minus 3. What's 1 plus 1?
2.
What's 1 minus 3? -2. And what is 2 times -2?
-4.
1, 2, 3, 4. Make dot. What do I do with the 3 dots? Okay? Now, again, just to read the directions, it says, graph the function, label the x-intercepts, the vertex, and the axis of symmetry. Did you find all those?
Yes.
Did you send Sydney Martin down to the counseling office?
Okay. Did you find all the pieces that it was looking for?
Yep. Yeah.
You sketched the graph, you found the vertex, you have the x-intercepts on there, and the axis of symmetry. Nice job. Okay? Hello? Yep. She's already on her way. Yep, bye. Okay, so here's what you got. On page, what page was that on? 62? To 63? 39 to 48, multiples of 3.
How do you memorize all this? Is there like a script that you write at night and just like cursive?
No. Then 54 to 63, multiples of 3. And 73.